David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, remember that you can slow down or speed up the playback to suit your needs. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today's topic is a review of sequences. We've been working in this chapter for about a week, and now we're going to finish up with a review. So let's get started. So the basic definition of a sequence is just an ordered list of numbers defined by a rule. So you can figure out what each number in that list is if you use that rule. So take a look at this sequence that I've put up here and think about, what is that rule? Well, if you came up with plus 3 every time, you're right. You just get the next term by adding 3 to the last term and so on. And you can go forever. Now, the thing about a sequence is it's nice to have a formula where you can figure out what the 30th term is or what the 300th term is. And we call that the explicit or general term formula. So we started by writing U sub n. And what that means is the nth term of the sequence. So your formula, you plug n into the formula and that spits out whatever term that would be. So if you're looking for the 8th term, you plug 8 into your formula, do a little math, and that's going to tell you what the 8th term of that sequence is. So take a sec, stare at this sequence here, and see if you can write the explicit formula for getting the nth term. Okay, so the deal with these is that your multiplier on your n is always the common difference. Okay, so it's going to be 3 times n. Now we need to take a look at what do we need to do to get the first term to be 7. So if the first term, n, is 1, so this part would be 3, so we have to add 4 more to it. So this sequence, the nth term is derived by this formula, 3n plus 4. And let's test it. Let's go all the way out to the 4th term. 3 times 4 is 12, plus 4 more is 16. So it works for our sequence. So that's the explicit formula, okay? Now, there's another type of formula called recursive. And the recursive formula, I think, is not quite as valuable because you need the previous term to get the next one. So using the recursive formula to find the 50th term of a sequence is kind of labor intensive. You'd have to calculate all 49 terms to get the 50th. So here's how this one looks. Actually, pause the video, see if you can write the recursive formula for this sequence. Okay, so what we do is we do un minus 1. So this means to get the nth term, we take the term right before it, that's the n minus 1, and what do? We add 3. So this would be the recursive formula for that sequence. Okay, now in this chapter we looked at 2 types of sequences, arithmetic and geometric. So let's take a look at the arithmetic sequences first. And an arithmetic sequence is just simply defined as a sequence where each term differs from the previous one by a fixed common difference. Now, you can say that in user-friendly speak just by saying, add the same number each time to get the next term, and you'd be right. So we have a way of finding the explicit formula. We just use this little cookbook form here. The nth term is always going to be the first term plus n minus 1 times the difference. That's all it's going to be. So what we're going to do is we're going to use this to generate the term for this sequence. So check it out. Actually, pause the video now and see if you can write the nth term formula, the explicit formula for this sequence, and then I'll do it in a sec. Okay, so let's go ahead and do that. Un is going to equal u1, that's 4, plus n minus 1 times the common difference. And what's our common difference here? It's 7. Okay? So now we're not done. We need to simplify this down a little bit. So I'm just going to carry my equals over here. I'm going to get 4 plus, this is going to be 7n minus 7. So my final form here is going to be 7n minus 3. And that's going to give me the nth term of a sequence. Let's test it. Let's test it on the 4th term. So 7 times 4 is 28, minus 3 is 25. So presto, we are there. After arithmetic sequences, we moved into geometric sequences. And geometric sequences work a little differently. Instead of adding a fixed common difference, we multiply the last term by a fixed ratio to get the next term. So each term comes from multiplying the previous term by a fixed ratio. Okay, so here's a sequence. 5, 15, 45, 135, 405. What's happening? How are we getting the next term? If you thought multiply last term by 3, you're right. That works for every term in this sequence. Our fixed common ratio in this case is just 3. Now here we have a general form equation, explicit form, for getting the nth term of a sequence. And it's just the first term times r, which is that common ratio, to the n minus 1. So to get the 7th term, you multiply the first term by the ratio to the 6th power. Okay, so it's always n minus 1 for that. And then there's another equation that's helpful to know about with a geometric sequence, is that if you want to find out the common ratio, you just divide one term by the term before it. So we write this as un plus 1 over un. Now let's use these two just to take a look at our sequence. First off, let's generate our explicit formula. It's going to be un is going to equal our first term, 5 times r to the n minus 1. And that's it. There's nothing more to say here, but we can easily use this formula to get the 20th term of this sequence, or in fact any other term we want. Now let's take a look at this one. Let's say we don't know what r is, or it's a little complicated, hard to see what r is. We just pick any term. Let's pick 135, and then divide it by the term before it. That's 45. And when you do that, you're going to find out that that's 3, and that's r. Okay, we did a couple other more tricky problems along the way with arithmetic and geometric sequences, where we used what we knew about the sequence to set up an algebra problem, which we could then solve for a variable. So let's do one of those for an arithmetic sequence. Here are 3 terms in an arithmetic sequence, and we're being asked to find k. And the secret here is to know that to get this term, we had to add the common difference to 21. So the common difference itself is going to be k minus 21. That's the common difference. Now the beautiful part with this is that 37 minus k is also the common difference. Since that's the common difference, it equals this. So we go 37 minus k. So that's the common difference, that's the common difference, they equal each other. Now it's just algebra, so I'm going to add k to both sides. I'm going to have 2k over here. I'm going to add 21 to both sides. I'm going to get 58. And then k is going to equal 29. And now that we found k, we can look back at our sequence and make sure we're right. If k is 29, then 29, we added 7 to get to 29. Or no, I'm sorry, we added 8 to get to 29. If we add 8 again, we're going to get 37. So that indeed does work. Okay, we did a real similar problem with geometric sequences. The setup is different, and we end up with quadratics sometimes when we do our solutions. So you've got to remember your factoring. That's going to come into play here. So here's a geometric sequence. First term is 3. Second term is 2k. Third term is 4k plus 24. Now, with a geometric sequence, remember that little equation we put up on the last screen? If I write 2k over 3, that's this term over that term, that's the common ratio for our geometric sequence. And that's going to be equal to 4k plus 24 over 2k, because this also is the common ratio, this term over that term. Now that I have these two fractions set equal to each other, I can solve that. My first step here is going to be to cross multiply. So I'm going to get 4k squared equals distributive property 12k plus 24 times 3 is 72. Now what I'm going to do is bring everything over to one side so I can set it equal to 0 to factor and solve. So I'm just going to bring these two terms over. I'm going to get 4k squared minus 12k minus 72 equals 0. And let's bring that up here. Now, the nice thing about setting an equation equal to 0 is you can start dividing one side by whatever you want to simplify it, and dividing 0 by whatever number that is just still leaves 0. So I'm going to divide through by 4. That's going to make this much more simple. I'm going to get k squared minus 3k minus 36. No, not 36. It would be 18, right? 72 divided by 4 is 18. Now this one is super easy to factor. I need two numbers that multiply to negative 18 that add to negative 3, and those numbers are negative 6 times 3, that's equal to negative 18, and negative 6 plus 3 equals negative 3. So my two numbers are negative 6 and 3, so all I do to factor is I go k minus 6 times k plus 3. This is all equal to 0. And now we use the zero power rule to solve. If this is 0, the whole thing is 0, or if that is 0. So I get two little equations here. K minus 6 equals 0, k equals 6. So that's one solution. And on this one, I get k plus 3 equals 0, k equals negative 3. So in this case, k has two possible values that work. Okay, lastly in this unit, in this chapter on sequences, what we did is we looked at arithmetic series. So a series is talking about the sum of a finite sequence. You can't, well, sometimes you can get sums of infinite sequences, but this time we're only looking at finite sequences. So what we're doing is we're summing up sequences. You got two formulas for that. Either one works, just depends on what you have. If you have the first and last term, then you can use this one. S sub n stands for the sum of a sequence with n terms. You just do n over 2 times the first term times the nth term. So if you have those two terms, this is the formula you need. But sometimes you don't. You might not have the last term. So you can also use this formula. This is n over 2 times twice the first term plus n minus 1 times the common difference. So you notice that really all we need here is that we need to know how many terms, we need to know the common difference, and we need to know the first term, but we don't need the last term. Okay? So let's take a look at a sequence. Here's 2, 9, 16, 23, 30, 37. Okay? Common difference is 7. I have my first term. It goes on and on and on and on. Now here's the request. Find S sub n, the sum of the sequence, for n equals 30. So what they're saying here, or what I'm saying, is that here's your sequence. What's the sum when you have 30 terms? I'm not showing you the last term. Now you could figure that out. You could add 7 and add 7 and add 7, but that's a bunch of steps. We can use this formula right now, because all it needs is the first term, which we have, the number of terms, which we know is 30, and we need the common difference, d, which we can tell by looking at the sequence is just 7. So let's do a plug-in. S30, because now we know which term, the number of terms in our sequence. It's going to be 30 over 2 times 2 times our first term, 2 times 2, plus 30 minus 1, so let's just do that, 29d. Now d we know, 29 is 7. So check it out, there's no more variables in there, we can do the math on this. Let's just carry it over. This is going to be, I love canceling. Cut. All right, so let's just bring it over. I have 15 times 4 plus, now 29 times 7, let's see. 30 times 7 is 210. So we have 1 less 7, so that's going to be 203. I hope I got that right. So S sub 30 is going to be 15 times 207. Now I do need my calculator. Okay, 15 times 207 equals 3105. So that's the sum of this sequence. Okay, the next topics that we would have covered had we not run out of time this year would have been geometric and infinite series. Okay, so we do sums of geometric sequences, okay, that we can sum them up, and there's a formula for that. And then we also look at infinite series. So we start by looking at finite geometric and arithmetic sequences because we know how big they are, we can sum them up. But infinite series sometimes have sums and sometimes do not. Now that you've watched the video, jot down some notes or questions for our next class. You can also re-watch the portions of the video that you didn't understand so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.